Okay, so let's start. I think things are getting broadcasted. Yes. Okay. So we will dive deep into um, the blockchain technology. Basically, we will look into the Bitcoin blockchain. This was the first blockchain network that was created. So I hope everyone of you have sent someone some money, right? But like, do you really know what happens when we click on the send button? Almost nobody does, because for normal bank payments, um, what, it doesn't matter. You simply touch the bank. Okay, so um, now this Bitcoin is interesting because we don't need to trust anyone. In a normal banking system, we need to trust the banks, but in this Bitcoin system, the blockchain network, we don't need to trust anyone. So what we will do in this uh, introduction session, that we will follow one transaction that Alice sends some Bitcoin to Bob. Okay, 0.05 Bitcoin to Bob. Uh, we will follow this step by step. So what is the concept of blockchain? So blockchain is very in just a minute. Like, if you have any question, you want to ask anything, then you can pause me and ask, because the main purpose of this session is that you should understand this concept. It should not be like I have given the session and then you are looking into Google like what exactly is blockchain. So understanding is the main purpose. Rest everything is secondary. So you need to pause me and ask me question that you face. So before we follow Eli's transaction, we need one building block. So a blockchain is a shared is just a shared digital notebook. So imagine a ledger at a bank. Um, a list of every transactions are stored in this digital ledger. You understand what is a ledger?
Yeah.
Like, it is a notebook in which we write, this person has given this person some money, that person has given some other person some money, and like this all the transactions are written into that notebook. Okay, so that is a ledger. It is a digital ledger and it is shared. In banks, the ledger is not shared with everyone. Only bank people, the people who are working in the bank, they know about that existence of the ledger, what all entries are written there. Not everyone. Okay, maybe you might know some, like you have a passbook, then you can know these are my transactions, but you don't know the transaction of other people also, right? Um, so the difference here is
Yes.
that it is a shared digital notebook and it is accessible to everyone. So this ensures transparency, and one important thing is that no one can change it. No unauthorized some person like who is uh, not allowed to change can change any of the data in the ledger. So once it is written, then it is simply immutable. It cannot be changed. That is a very important point. Okay.
Okay.
So now what is the first about this Bitcoin? So traditional systems are centralized, and Bitcoin is a peer to peer network. That means in a centralized system, uh, there is one person who will need to allow a transaction, who can censor a transaction. But in Bitcoin, there is no single authority. That means there is no single point of failure. There is no single censorship point. So what it does is it enhances the security, and it makes us easier to trust, because it is difficult to trust a single person. But if there is a group of people, uh, then it is easier to trust. But here it is not a group of people, but the complete network that is making trust and decentralized. We are not trusting a single person, but the whole network. Um, so I will talk about this when I will walk you through the example of transacting the tokens. So so there is no single headquarter, no CEO, no customer service number. So if even if the half of the network goes offline, even then the transaction will keep on running. There will be no problem at all. But in the banking system, if some computers fail, if some branch goes, some network issues, some power failure happens in some branch, then things halt. Okay, but here even if the half of the network goes down, then also transactions keep on happening. That is one other benefit of having decentralized network. No single point of failure. Um, so yes,
Okay, okay, getting it.
like, do you have any question?
No, I mean, I have a doubt like how it works, how how the like how some how everyone is managing everyone's transactions.
Okay, so we will look into this, and for now I can tell you that it is a system of distributed computers. Uh, so all the computer contain the complete data of the transaction that had occurred in past. For example, I send you some Bitcoin. You send it to Sushmit. Sushmit sends it to some other person. So all these transactions are being written in the in a maybe in a database. Okay. Now their database is not in just one computer but in all the computers in the network. Okay. So now one question can be like, these computers are called as nodes. Now one question can be like, how many nodes are there currently? So currently there are around 15,000 or 20,000 public nodes. Apart from that, anyone can host a private node. Okay. And this number is not fixed because anyone can create their own computer as a Bitcoin node.
And for Node, he get some bitcoins.
Yes, that is an interesting point. It is not always that he gets some incentive to run the node. Only the miners gets incentive. Other people they just get this incentive that they are transacting in a decentralized network, but no direct incentive for hosting a node. So although it
No, no,
works,
no, no, no. If there is no incentive for hosting a node, so why will people run their electricity and why will they?
exactly good. Yes, yes, that's what I was explaining that. Uh, if I'm a Bitcoin miner, then I will get some incentive to run the node. I will get some Bitcoin if I mine it. Uh, for example, the current rate is we get around 3.125 Bitcoin if I mine one block. Okay, and that means like around I think that is a lot of money. I don't remember the current exact rate, uh, but that is sufficient to power our computer. But if I am not a miner, then what is the incentive that I am getting? The only incentive that I am getting is I am creating a network on which people can transact without trusting a single central authority. That is the only incentive. So no direct incentive of hosting a blockchain node. So what happens is that these public blockchain nodes are there. Some private are also there. Someone who is just curious about the technology, or who is exploring it into detail. They are hosting a node for you. Okay. So whenever you make some changes in your wallet, like you want to transact, you want to send some money to someone, then I will update that into my node. Okay, so we'll dive deep into this. But for your question, the answer is that someone who is hosting a node, he does not get any direct incentive. Uh, he just get the indirect incentive that he is creating a network which is decentralized. Uh, that someone who is not hosting.
Self-satisfaction type, like contributing to Wikipedia page.
Yes, 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 like that.
Self-satisfaction type. Yeah.
Yes. All the data into my nodes. It takes hours because there is around more than 20. I don't remember the exact, but it is in multiple GBs. I think more than 100 GBs. I don't remember the exact number.
And it is necessary to containing all the nodes data.
There are options. There can be light node also, which will just keep the recent data, but they are not making the system fully secure because there can be some. Uh, Actually, as I will explain the system, the blockchain. Let's move to the next slide. There I will answer it in a better way.
Okay.
And what is the difference between mining and hosting some data in Node?
Okay. So while let me hash that. You know what is a hash? In hash, that is a one way function. For example, I can say that 2, 3, 20, 2, 3, then 10, 12, 13. All of these have t in their starting. So I map them to t. Okay. So 2 will map to t, 3 will map to t, 10 will map to t, 12 will map to t, 13 will map to t, 14 will not map to t, it will map to f. Okay, so this is one hash map. Now what is the problem, what you will say a feature of this hash map is that I cannot reverse it. If I want to get like which number got mapped to t, I cannot get that because multiple numbers can map to a same hash. So what we do, the simple idea is that when we hash it, then if a single change is made in the previous data, the data contained in the previous block, then the hash changes. Okay. So that means someone has changed the data. That means the data is invalid. So that is what makes it immutable. Blockchain is a chain of blocks. Every block has multiple transactions. And what we do is to make it immutable, we hash the complete the data in the block and store it in the next block. Okay. So when I will this creates the chain. So my first block is linked to the next block. Now what we do is along with the hash of the previous block and the data of the next block, we hash it again and store it in the third block. Okay. Now if some change is made in the first block, then the hash will change of the next block. The hash that we are storing of the first block in the second block, that will change, and that means the data of the second block has also changed, right? So if it is confusing, you can take hash as simple 24 to 60-bit string. So hash is nothing but a let's say 50-bit string. Fine. 50 character string, sorry, 50 character string, that is a hash.
Yes.
So I am explaining how this blockchain network is immutable. I will try to explain once again. What we do is some data is there in every block. Let's take the first block. It has a header and it has a data. So in the header we store the hash of the previous block and some other metadata. And in the data we store the in the body we store the transactions. Okay. So in the first block there will be no hash of previous block because that is the first block, genesis block, right? Okay. So in that way we hash the first. Now when we have got the first block, all the transactions, then we hash it. We store the hash in the second block's header, and in the body are the transactions of the second block. Now we hash the second block and keep the hash in the third block header. So in this way we keep on hashing and storing in the next block. This creates a chain. If any of the block in between gets mutated, someone changes the value, then complete link gets distorted. That changes. So we simply say that data is invalid. Okay. It is fine. I will explain it once more. But let's come back to the questions that. Can you repeat the
One
question
second,
once again?
one second. Uh, you are telling that there are multiple blocks. First block have some data. Second block contain the data of first block, which has some data plus some metadata. about location of first block and second block, मतलब third
Yes,
block.
yes, somewhat like that. Yes.
And a third block will contain the transaction data of second block and metadata for third block, or
Right.
normal metadata connecting second and third.
Right.
In this way, if third block collapse, then the whole chain breaks and whole data is collapse.
Yes, not just
So
the
this
third block, but even if in the first block, I make some changes. Okay.
if in one first block you make changes, the whole chain
Collapses.
got distorted
Yes.
sequence wise,
Yes.
and whole data is very secure in this sense.
Yes. So, in if either the complete data is true or it is false.
Yeah. Either the complete block have correct data, or
It is not valid.
else it is not valid.
But
And
why we are storing the first data blocks, first block data to the second block header?
We are not exactly storing the first block data, but we are hashing that. Hashing means compressing it. Compressing it in a way, for example, the data can be maybe like multiple lines of strings. Okay, each line containing maybe 1,000 characters. Okay, but but the hash is only 50 characters string. I'm just giving example. It is not exact numbers. Okay, just 50
Yes, but
characters. So
what is the need of it? But what is the need of it? Because we have already the first block in the previous node. Right?
So we are hashing it because if now someone changes some value in the first block, then its hash will change, and hash changes very unpredictably.
Okay, get it. Then it is required for matching purpose. Right?
Yes, because it is required to ensure that it is immutable. The previous block is immutable.
and the whole chain is stored in multiple nodes.
Yes,
And how many chains are there?
like we are talking about Bitcoin, so that is the single chain we are talking about. Um, so there is only one chain, but data is huge. Because this is a
One,
single chain from 2009 when blockchain was the Bitcoin was started.
so the chain that is, you are saying one chain for Bitcoin, how much GB it is?
I think it is 100 more than 100 GB. I think I don't remember exact, but I think it is very huge. So
So
that's why we want to save data. That is another reason that we are trying to compress it. We don't storing the same data again and again in every block, right? In block two we are.
yeah,
Hmm.
so the whole 100 GB is stored by nodes
Yes, each of the
in
nodes.
local data centers.
So node is like in India there can be multiple nodes. Similarly, can be in US, in Europe. Anyone, even if I want to host a node, I can host a node, but I need to pay for it. I think it costs around 20 dollars per month, or sometimes $100. Um, so I need to get all the. I need to keep it running all the time. I need to get that much storage and install the blockchain software into it, clone all the data. So um, a minus
And
have incentive to run the node, but a normal person does not have any incentive to run the node. If I
one
use,
second, there is a chain, only one blockchain that has 100 GB of data, and this is about Bitcoin, and there are a lot of Bitcoin. I think there are more than 1 lakh Bitcoin, or
okay,
particular
so
number of
I think
Bitcoin.
you are confusing
So
with the there are many. It is not like single Bitcoin, and the Bitcoin blockchain is one network, and similarly there is a Ethereum network, Solana network. Okay, so these are
no.
different chains.
I am telling that there are 3 lakh Bitcoin. Let's suppose there are 3 lakh Bitcoin. So all 3 lakh Bitcoin data are stored in one single black blockchain. Am I right?
Yes, yes.
Okay, okay.
Okay, so it will be more clear like what exactly is meant by keeping one Bitcoin. It is all about trust. That people trust that you have the Bitcoin. That's it. We will see how it happens. We will follow one transaction. So uh, uh, so what happens is Alice and Bob, two characters are there. Alice wants to send 0.05 BTC to Bob. I think this will be around how much will be 0.05 BTC? Can anyone tell me in dollars?
It is 3,50,000 rupees.
Yes, so it is a huge number, and Alice want to send 0.05 BTC to Bob's address. But before, what she does, she opens her wallet app. Okay, so there is a MetaMask wallets like MetaMask, Coinbase, multiple wallets are there, which can be installed on our Chrome or in our mobile. Okay, so let's say she uses her phone wallet, and before anything leaves her phone, her wallet does something crucial. So let's move to the next slide. What happens? So Alice signs the transaction. What is meant by signing it? There are Alice has a pair of keys, a public key and public key is like the account number, bank account number. Okay, the public address that anyone can see, and a private key that is secret number that should only be with Alice. No one else should know that number. Okay, so both are like strings of maybe 50 characters. For simplification, I'm saying 50 characters. Okay, they are like 64 or maybe 72, 80. I don't remember the exact number. Okay, so now what she does is she enters the private key into her wallet, and after she enters the private key, then only the wallet understands that okay, this is the person, and this person wants to send 0.05 BTC to Bob. Now this this wallet will this is the signing process. In signing, what we there is a public key and a private key. Public key is accessible to everyone, and private key is accessible to the person only who signs. The main idea of signature is that I made a transaction that I am sending 0.05 BTC to Bob. This on this I made a signature. Now no one can forge it, but anyone can verify it. No one can forge it, no one can modify it, but anyone can verify it. That this transaction was approved by Alice only. Okay, so this is I have given the proof that I have the knowledge of secret key without revealing my secret key. Okay. Um, so
Yes, I'm getting it.
okay. So now anyone can verify the transaction, and now the wallet is sure that Alice has given this want to make this transaction, so it uh, broadcasts to a nearby node. Okay, and let's move to the next slide. The transactions spreads. So what happens is it for example, I am in Alice is in India. Okay, and she wants to transact 0.05 BTC. She wants to send 0.05 BTC to Bob. Now wallet is registered. Wallet is not a complete node. It is installed on a phone or a laptop. You can't install a node on your laptop or phone because it has a lot of data and a lot of computing is required. Okay, we need a separate computer for it, but no one affords this. But everyone can afford having a wallet. So wallet is a lightweight application. What it does, it just ensures that you are the person who wants to make some transaction, and it then connects it due to the nearby node. Okay, so in my phone wallet, I just write that I want to make this transaction to Bob 0.05 BTC. Then it communicates to the nearby node. Once it gets to the nearby node, maybe the node is in someone is hosting a node in Delhi. Okay, so once it goes to his computer, he then propagates it to other nearby nodes. So this is like gossiping. How a gossip spreads. Uh, Someone says that okay, that this is an event that is going to happen. Then I tell it to my few of my friends. Then they tell to their friends. It keeps on spreading. So similarly, it happens in the node. Wallet has made wallet has communicated to a nearby node. Then those nodes will communicate to their nearby nodes, and it keeps on spreading. That is called the gossip protocol. This is called flooding. Okay.
Okay.
So let's move to next slide. Now the transactions we are there can be multiple transactions. It is not just that Elias is sending some money, some Bitcoin to Bob, but there can be multiple people who are sending Bitcoin to someone. So all the transactions are stored in something called as mempool. Okay, it is like I will get a stack of transactions, like hundreds of transactions are there. If I am a node, I can see all those transactions. These are the transactions filed. Now comes the role of miner. So what miner does is he will pick up those transactions who has given higher fees. So with every transaction, for example, if I want to send 0.05 BTC to someone, that is around I think $3 lakh. I don't remember whatever that number was, but I also need to give
No, 3,50,000
$3,50,000, right?
rupees.
Rupees, okay, fine. If I send 3,50,000 rupees or 0.05 BTC, I also need to pay a small fees. Maybe very few BTC, maybe 0.0001 BTC, like that. Now miners will select those with higher fees, who have given higher fees on priority. That I will, for example, in a block, they can only include 100 transactions, not 1,000. Okay, so from 1,000 they will select the top 100 with highest fees. Okay, now how do they mine? There are around 15,000 to 20,000 public nodes, and some of them are mining nodes. Those mining nodes will pick up top 100, let's say top 100 transactions based on the fees they have paid, and then they will solve the puzzle. They need to solve a puzzle, and for solving that puzzle, they will have to use the computing resources. The solution of the puzzle has to be generally comes out within 10 minutes. Actually, there is not a single miner, but there are multiple miners, and they all are racing. Whoever solves the puzzle first, they will get the award. So that is a risk. Like you are putting a lot of energy and time. Time is okay, but a lot of energy is being invested into it, because solving that puzzle requires a lot of computing power. Okay, a lot of electricity. So that is being. It is not just we are hosting a node, but we have to run very specialized integrated chips, and that requires a lot of electricity. It is not like a simple node, but it is more than that, much more than that. You are investing a lot of effort, and if you did not win the race, you get nothing. But maybe if you keep on trying for months, then you can win sometime, and even getting 3.125 BTC is a lot. Like 0.005 is 3.5 lakh rupees. So 3.125 is multiplied by 60, I think. So that is a lot.
Miners mine, okay, get it, but what is the reward for them?
Yes,
How will
they solve the puzzle, and mining means they say that okay, these 100 transactions are perfectly valid. Okay, anyone can trust these transactions, but they will get the fees that for example, Elias has paid while sending money to Bob. That is very small amount, like 0.0001. That is not much. But the major fees that they are getting is 3.125 Bitcoin per mining, per block. So if they mine one block, they get this 3.125 BTC. So that is a major reward that they are getting. That is in crores, I think.
But what is the need of the mining? Because we are doing just transaction at it is. I mean,
Yes.
what are they doing?
Like if I say that if I do a fake transaction, then who will invalid that? If I make an invalid transaction, then people can trust that also. So I can do double spending. For example, I will say that I have sent some 0.005 to Bob and 0.05 to Chris, for example. Then and I show only one time, that is called double spend. I use same 0.05 BTC spending twice. So these kind of fake records can be invalidated if we look at the record from starting. So every node by default that is automated into the software. If you install Bitcoin software, that you will need to verify all the transactions from the past. Okay, but even then, if someone this is in milliseconds, it is very easy to verify because we just need to verify the hashes. For example, if you have already, if I have paid 0.05 BTC to Bob, okay, and then I am paying the same 0.05 BTC to Chris, then that is invalidated because it will show me and I have balance of only 0.05 BTC. It will show invalid because my balance will be zero. Then how can I send it to send again to 0. To Chris? So if I track the transaction from starting, then I can very easily tell that okay, this is an invalid transaction. Okay, that is being done in every node. But even then, someone can say that even though it is invalid, but I will say it is valid, and I will propagate it in the network, just because I am a faulty node. I just want to cheat the system, okay, or just because I have made a transaction and I am owning a node, so that's why I am spreading out false information. Okay, someone can do that. To counter this propagation of false information, we are saying that only that block is valid which has been mined, and mining takes around 10 minutes. So we will wait unless 10 minutes have passed. Before 10 minutes, we can't be sure that okay, this transaction has been confirmed. Even after 10 minutes, we will wait for an hour, but that is a second part. But for now, we need to wait for 10 minutes unless it is mined. Now, in mining, someone is using a lot of electricity to mine a block. Now, if that he is including a fake transaction, then later on that will be figured out, okay, by some other miner, and his reward will be taken away. So why someone will waste a lot of energy in mining some wrong block? That is the idea. This is called as proof of work. So the basic idea of mining is that we want people to spend their energy and resource and time so that they don't cheat. So they don't mine validate a wrong transaction.
Okay, man. That means miners just to validate the transactions of everyone, right?
Yes, exactly.
And for validating purpose, I guess they validate the hashes of the blocks of the
Yes.
nodes.
So validation is very easy. Solving the puzzle takes time. They need to solve the puzzle that takes around 10 minutes. So as to ensure that the miners don't include a false transaction. They need to give the proof of their work. They need to spend energy. Energy means money. So no one will waste money. That is the idea.
And who are giving the rewards to the miners?
So it is automated that it is in the protocol. It is in the rule set that miners will get the reward if they mine a correct block. They will get the reward, and if they mine a wrong block, then what happens is let's move to the next slide. What happens when miners compete in the proof of work? So I think we have discussed this. Let me explain a bit here that when the miner mines a correct block and broadcast it, so everyone can be sure, okay, that um, that the transactions are valid and we can build upon this. Okay, we can mine the next that all this transaction is valid. Everyone has agreed. Um, so there is I want to tell a bit about the puzzle that or we can discuss it in some later session. This puzzle is also interesting. The difficulty level of puzzle keeps on increasing every 2 weeks. So that because the creator of the blockchain understood that people will come up with higher computing resources, okay, and they will be able to solve puzzles quickly. So what they will do is what the protocol does is they automatically increase the difficulty level of puzzles as people are able to solve it in lesser time. For example, if the miners are able to solve it in 7 minutes, then it will automatically increase the difficulty level of the puzzle, and in 2 weeks it anyways increases. So due to that, from 2009 till today, it takes 10 minutes to solve the puzzle. But what exactly that puzzle is, that we can discuss later.
And the puzzle is solved by computers only.
Yes, basically they have to run a brute. For example, yes, they are solved by a computer using brute force method. Yes, correct.
Not by human
No,
intelligence or
no human intelligence, no AI, no intelligence is required. It is a simple brute force puzzle. We need to run some kind of loop, and that loop will keep on executing. So we need to basically spend our energy. Computation.
and one doubt, if there is some transaction, and then there are like 5 miners who compete to mine that transaction, and one of the miner win. Am I right?
Yes, the person who has solved the puzzle in the earliest wins.
So when the rest four will try, but they fail.
Yes,
So they will get nothing.
yes. So if these 10 minutes have proven them unlucky, maybe they can try their luck in the next 10 minutes.
And who validate that the transaction is true and not false? The all 5 competing miners.
So it is
Uh,
not just the miners that validate that transactions are true. Every node by default checks the transactions are true or not. Unless some node says like a mischievous node, they will broadcast a false transaction, showing them that is correct one. Okay, but and the miner node also will validate the transaction. Now even the miner can include, if they want, they can include a false transaction, but they will be at loss because they will spend all of their energy to validate a wrong block, and let's say it got validated, okay, and afterwards they will lose their money. So what is the use? So no miners. That is the thing that is protecting the system.
win-win situation.
Uh,
If if you stay to the truth, you will win.
yes, if you stick to the truth, you will win. Else
Yeah.
you will definitely lose. No matter what. So this is called as proof of work. This is protecting the complete system. The longest chain rule. So sometimes it can happen that two miners can find the block simultaneously. What happens is, how do I know that, okay, I have found the block, I am in India, I am a miner, and I have mined a block, okay, and I have broadcasted to nodes in maybe Delhi, Mumbai, and nearby cities. Now another miner in US has also mined, and he has also broadcasted it to nearby nodes, maybe in their nearby states. Okay. Now those nodes have their own different chain, right? They will be showing as a different chain in front of the, let's say, a block number X was common in both of us. The me in India and some other person in US. Okay. After that, I append to it block Y, but the person in US append to it the block Z. Okay. Z has been validated by the miner in US and Y has been validated by the miner in India. Now I have a chain with a fork, right? So what happens is, we wait for a next few blocks, okay? Maybe y1, y2, y3, z1, z2, z3. So the one that is picked by most of the miners, that will be validated. Means the block that is the chain that is the fork that is the longest. For example, after some time, all the networks merge. The India and US networks will merge eventually, right? It is not like India network will stay in India only and US will stay in US only. They will come to Europe, come to Middle East countries, and they will merge, right? So at that time we will see like which fork is the longest. For example, y1, y2, y3. Three blocks has been added after that, after y. And on the other hand, after z, only z1 has been added. So clearly, this the longer fork will be accepted by the community, by the network. So that is the longest chain rule. The probability decreases as blocks keep on getting added. So as a rule of thumb or simple by convention, we are sure that our transaction is valid if 6 blocks are added in front of that block. So if you have made a transaction, then you need to wait for 10 minutes, and after 10 minutes you are almost sure that your transaction is valid. But to be ultra sure, you need to wait for 1 hour. If you have made a very huge transaction, you should wait for 1 hour to ensure that it is not in a fork, because the transaction in a fork will not get will get back to the mempool. You remember the mempool that we discussed a few slides back. So it will go back to the mempool, and we will wait for next 10 minutes to get it validated by some other miner. Okay, it will not get lost, but it will get back to the mempool. So if you are making simple rule of thumb, if you are making a transaction worth like $10, then it can be instantly validated. As soon as it gets into the mempool, then only you can be pretty sure that okay, it was a valid transaction, and things can go on instant validation. Next, if it is like a big amount, let's say $10,000. So you should wait for at least 10 minutes that okay, some miner has validated it. Okay, but if it is a very big transaction, like maybe in lakhs of dollars, then you should ideally wait for 1 hour or more than that to be ensured that okay, this transaction is validated and it is in the longest chain. Okay, so so this is the full journey. First we sign on the transaction, then we broadcast, and then the gossip protocol that relay transaction to the neighbors. So once it is mined, then we are confirmed that okay, the transaction was valid. After that, we wait for a few more blocks to be added, and then it is done. Okay, so this is it. That we don't trust any central authority like government or banks, but we trust the math. That is a very big idea, that we don't trust humans which are very often which very often break the trust, but we often the math on which everyone universally agrees upon. So that is the core idea of blockchain. Okay, so any question, any feedback?
Yes, I mean, some doubts are like why the puzzle gets harder for I mean why it is time taking more for huge amount of money, because the less amount money it taking very less amount of time, and the huge amount of money taking very much amount of time. Why?
Okay, so we keep timing is set as 10 minutes because we want the message to be broadcasted to all the nodes, and that will take time, right? It cannot happen instantly. For example, 10 nodes are nearby me. There is some internet speed. I send the data to nearby nodes. They will send. That will take time, right? So 10 minutes is chosen as convention. That okay, that in 10 minutes that things can be broadcasted to all the nearby all the nodes. So that is the convention that was taken by the inventor of this technology, who is known by the pseudonym Satoshi Nakamoto. It is not a real. No one knows if he is a real person or a group of person. It is pseudonym by which he published the paper, uh, and he vanished after 2011. So or 12, I think. So that is the core idea.
Okay.
We need
And
10 minutes,
I
so we can't be very fast because things take time to get broadcasted, and why we can't be very slow because we uh, we don't want people to wait infinitely for a very small transaction. So this was a trade-off taken by the inventor of the Bitcoin. 10 minutes. Now to ensure he understood that the computation power will keep on increasing with time. So we need to make the puzzle harder and harder and harder. So he put it into the protocol that how to make it harder. So what I can talk about the puzzle also. Uh, we can
uh, I
uh,
have another doubt. You said that many those person who do transactions had a fees for his transaction, and based on the fees priority, the miners mine them. But if someone didn't added some fees or just added a little fees, and the miners why the miners will mine the less fees transaction, they will mine high fees transaction, then that will result the less fees transaction will go in the loop.
Yes, yes,
uh,
you're correct. So what happens is after 2 weeks, the all transactions are discarded. So that's why you need to keep some wallets have this feature. They tell you like how much fees you need to keep it so that it gets picked up by the miners. So you need to keep competitive fees, not very low, else it will never be taken up.
okay, then okay, get it.
So yes, you are correct that it can get discarded. It has some 2 weeks, 2 weeks or exact I don't remember, some kind of time period after which it simply gets discarded, not even as
and
an input.
and so suppose I am sending money to Susmit, and like very less amount of money, like 0.0001 BTC, and I just want to send him money. I don't want to validate my transaction. So why I will put a fees for the transaction?
See, you will have to put
One
the
one
fees
second, one
once.
second, Sachin. Actually, his question is, he want to make transaction private. Am I right, Guru?
No, I wanted to ask if I don't put my fees, another fees for the transaction, will it not
That
happen?
transaction does not, unless it is mined by a miner, the transaction means nothing. It simply means you because no one trusts that transaction. So how does that mean? Even if you send a very less amount of Bitcoin to someone, unless it is mined by a miner and it is included in the blockchain network, the blockchain chain, right, the big chain that everyone clones, unless it is included there, that till that point that transaction doesn't mean anything. So you need to give a fees, and that fees has to be competitive so that it gets picked up by the miner.
Okay. And this fees system, I think this is not fair, right?
What it is?
Like this is not fair thing.
No, it is a fair thing. See, some miner is spending his resources, his money to mine to validate your transaction. Anyway, you pay to banks some kind of fees so that they maintain all your records. Okay, so that's how they are getting their salaries. Either you are paying them directly or by through the taxes. Anyway, anyhow you are paying them. So similarly, we need to pay those who are maintaining this network. So those people are miners. So we need to pay them. The 3.125 BTC reward that will keep on diminishing every I think 4 years. Every 4 years, approximately 4 years, it keeps on halving. So last time it changed from 6.250 to 3.125 in 2024. So maybe in next few years it will halve down, and then it will keep on halving. So that is built into the protocol that the reward will keep on diminishing. I think it started with I don't remember exactly, but it was a huge amount in initially days.
But I
And
guess if the rule exists, like we have to give competent fees, then as the performance, like the resources to mine transaction is keep increasing, then we have to put extra fees, like we the fees will be kept increasing, and that's why uh, the value of the transaction will be
If fees will increase a lot, maybe more people will take up mining business. If a lot of people are paying a huge fees, then more people will get into mining business, and that will decrease the fees because people will see that even lower fees transaction can be picked by miners because there are more miners than before. So fees will automatically reduce.
and and the price of Bitcoin keeps increasing in 4 years. So the
The
effective
price of
money
Bitcoin
they get
that
is
depends.
more.
Yes.
The effective money that a miner get even after 8 years will be more as the price of Bitcoin keeps on increasing.
Yes, that is a good point. That price is keeping increasing. That is a very good point. And let's see. It is all about the trust. How strongly people trust this protocol. But they will be able to trust only when they will understand the protocol, how it actually works. But currently, very few people understand this. Although a lot of people invest in Bitcoin, they transact, but I think very few people understand clearly. As trust will increase, the price will keep on getting higher, and it will reduce if trust reduces. So maybe you're correct. Maybe people are getting only one Bitcoin as a reward, but even that one Bitcoin can be much higher than the value currently. That is possible. But it will see in 20 I think in 2150 or 40 there is a limit to number of bitcoins that can be. It is 21 lakh total bitcoins that can be mined. So once all the bitcoins have been mined, then there will be no extra mining. So there will be only validation. No so there will be no reward after that. So that is a hard limit. After that there will certainly be simply be zero bitcoins.
Simply there will be zero Bitcoin to be purchased. All
No,
Bitcoins
to be
will
given as reward to miners. Purchased transaction can take place all the time. Like 21, there is a limit. There is finite money, finite Bitcoin transactions can be there, but the miners will not get any reward. They will only get paid from uh, the price extra price that people pay while transacting. That's it.
okay. So Bitcoins are limited, like 3 crore or 30 lakh something.
21
So
lakh.
uh, so they keeps on trading, and the price of them keeps on fluctuating based on demand and supply as well as trust.
Yes, I think main factor is the trust, and you can and demand supply is also a factor. Yes. I seriously believe if a lot of people will understand this technology, then the price will simply go up and it will become reasonable, not keep on increasing. Also, there needs to be some improvement in this technology because I think, like some convention like 10 minutes, I think it can be some better number, not exactly 10 minutes, because maybe it is faster to communicate to all the network, everything in the net. Maybe it can be made to 2 minutes or 3 minutes. The 10 minutes time for solving the puzzle, that is not required. Other thing can be people who have a lot of bitcoins, they can also validate the system so that just like there is one other protocol called as Ethereum, the other blockchain. They do not use proof of work. They don't want everyone to mine to solve the puzzle. They simply say that those who hold a lot of Ethereum, they believe in this that they will not cheat the network. Else their Ethereum will become invalid. They will lose value. So on the basis of this, they can validate the transaction. So that is one
And
of the way called as proof of stake.
and there are a lot of instances that a lot of foreign nationals forget the keys of Bitcoin or lost the hard drive.
Yes.
So, can you elaborate on this?
Yes. It has happened a lot. A lot of bitcoins has been have been lost due to this because people have lost their private keys and now they, they they simply can't access them and no one can access them.
They forget the key or the password of accessing Bitcoin, so they lost them all.
Yes, and now those bitcoins have simply gone away from the circulation. They don't exist. It is simply like money drowned in the sea.
Okay. And what about hard drive? Like I'm not getting like Bitcoin are stored in a cloud or some nodes, and that data is stored in some internet or cloud or
So
anything.
there is a network
But
of nodes,
what about, yeah?
like 15,000, 20,000 nodes I had mentioned in the starting. So those all computers
So
keep the data and they are in sync, and that is where Bitcoin is getting the value.
so the hard drive is lost means the 50,000 nodes, some nodes are lost. Am I right?
So if let's say if 10,000 nodes have lost their hard drives, okay, the
No,
whole
no,
network exists.
please repeat.
If there's a network of 20,000 nodes, okay,
Hmm,
public nodes, let's
hmm,
say for now,
hmm,
there can be much bigger network that is simply not known to us,
hmm,
but these are public. So let's say 20,000 nodes are there. Everyone
hmm,
stores the complete blockchain into their hard drives. Okay, let's say 10,000
hmm,
of the nodes.
hmm,
Something has happened, and all of their hard drives have been damaged, destroyed.
hmm,
Okay, now they
hmm,
have lost the data, but the remaining 10,000 nodes they still contain the data, and their data is correct. Now the other
hmm.
10,000 nodes can pop up. Okay, new 10,000 nodes can form, and again the network can become of 20,000 nodes, and they will again contain the same data. Until and unless even a single node is existing, the data is safe. The Bitcoin is valuable. Okay.
So there are 50,000 plus nodes, and even if one node is existing, all data is secure, all
Yes.
data is safe.
Yes.
That can be replicated
Yes.
into. But I have read an article that a US citizen lost a hard drive containing some Bitcoin, and he lost Bitcoin. So I'm not
No. It was. I think.
addressing that.
I think it was not hard drive. Maybe you are talking about some kind of paper wallet kind of thing. Uh, there is people store their secret key. For example, you store the secret key that is without the secret key you can't access the blockchain. You can't access the Bitcoin. You can't convert that to any other fiat currency. And if someone else can gets your secret key, then they get all your money, all your Bitcoin.
So the
So to
secret
prevent
key,
that,
isn't secret key like a password of our Gmail?
yes, it is like that. It is like that, the password of the Gmail. But uh, not exactly like that, but it is something like that. You need to keep it with yourself. So for that, what people do is they don't even want to show it to any kind of computer. So they keep it on paper or store it in their not on the internet, but simply on their maybe on their hard drive. Okay, the secret key, not the data of the Bitcoin, the blockchain. Only the secret key thing is stored in there, either in the paper wallet means uh, that is simply writing the password on a piece of paper, never keeping it giving it into the software. Then they can store it in some kind of hardware wallet is there that I am not very familiar with this concept. I simply used the software wallet, the Chrome extension, and the phone wallet. Uh, but there is also you can store it in some kind of a pen drive like of thing, and from there you can use that. And if that pen drive is lost, then your all cryptocurrency is lost.
So
But
it is just
Okay.
like a text file.
mhm.
So it is just like a text file which is containing 50 character of string.
Yes, that's it. Nothing more than that. Exactly.
How many characters or letters are in key?
I don't remember the exact, but it was around 50, around 64, 80. I don't remember exact.
Okay, so that is that in paper or lost or in hard drive or pen drive is lost, then the access or
Actually,
that Bitcoin
yes,
is lost.
actually, I know this technology. It is called cryptography. The whole concept is just encryption and decryption. If it what it means, like we everyone has two types of keys: a private key and a secret key. Sorry, a private key and a public key. And key is nothing, just a string, like a 50 character string, and public key also. And public key is known by everyone. Everyone knows everyone key, and private key is just known by me. And what is the concept of two keys? Like if I want to encrypt the data, then and I want to decrypt the data, then how it will happen? If I encrypt the data using one key, then I can decrypt the data using another key, not with the same key. So this
Wait
is
a
two
minute.
key
I am a
encryption.
bit confused here. You need to, I think, explain it once more. Can you also turn on your video while explaining? Is it possible?
Uh, okay, wait. I need
This concept is, I am also familiar with it. The encrypting and decrypting technique, public and private key. Public key is accessible to everyone.
yes,
Private is accessible to only the person whose
I
public
learned
key
it
belongs
in
to.
my BTech fourth year subject.
Actually, the blockchain is a combination of cryptography and distributed computing. Uh, someone who is well versed with cryptography will very easily grasp the concepts. Even the hashing part, I think you should be very familiar with it if you've done course on cryptography. Yes.
Like suppose we have two keys, okay, and this is private key and public key. We all persons have that, okay, and public key is known by everyone, private key is known only by me. And suppose I want to encrypt a data, okay, and this function is called two key encryption. Two key encryption, what is it called? There is there's another thing, one key encryption, that is if I am encrypting our data, then we can encrypt the data and decrypt the data using the same key. This is one thing, but there is another thing also. Like if I am encrypting one data, if I am encrypting the data using one key, then I have to decrypt the data with the another key. So if I am encrypting the data using private key, then we have to decrypt the data using public key. And if I encrypt the data using public key, then I have to decrypt the data using private key. So this is the concept. So how it
Echo,
works,
stop.
like the Alice sends money to Bob, and we use the technology to verifying purpose. Works like the I am encrypting the my name. Suppose I am encrypting Alice using my private key, and the data, that encrypted data, can only be decrypted by public key. And it is if I am decrypting the data, then uh, what is the result of it? Alice. So everyone knows that this transaction happened by Alice. So this is the concept.
Yes, it is like sharing the knowledge of that you own something without revealing that thing. Knowledge
Yes,
of knowing something without revealing that thing that you know. It is sharing this.
yes. So this two key encryption works in this way.
Yes, Sushmita has shared this puzzle. Let's open it. So I can quickly tell you about the what the puzzle is exactly. What we do in the puzzle, as you already are aware of these cryptography techniques. So what we do is we need to we are given like to validate this particular block. To validate a particular block,
Please explain puzzle
yes.
in
To
detail.
validate a particular block, we need to we have a target.
And one more thing. And there are statement like anything one man can imagine, other man can make real. उसके बाद signature लिखा है ना? तो ये मतलब this is very interesting at the same time confusing as well.
Where is it written? I cannot see.
So there is a quote as well.
Okay, okay, okay.
Everyone thinks of changing the world, but no one thinks of changing himself. Tolstoy.
Okay, okay, got it. Okay. So here, almost every peer has to work. Not it is not required actually. It is a protocol that is handling all of this. Uh, Even if some of the peers behave dishonestly, then also this protocol ensures that only correct transactions are validated. So coming
So
back to the puzzle.
this quote is like the comment section of a code we write.
I am not getting it.
If we write a code, then in comment we write something to explain to the validator. But the actual the role of the comment is nothing in the code itself. So
Okay, okay, yes, yes.
the quote is like without any use.
I think you are trying to explain the private public. You're giving. No, you're trying to give the analogy for private public key. Is it
Yeah,
so?
yeah, yeah,
Okay, no, it
yeah,
is not the correct analogy. In private public key, what we are doing is we are telling the world that I know something, but I am not
yeah.
telling that something to the world. I will get back to it after some time. But let's focus on the puzzle right now. What happens in a puzzle? Uh, in a block, we are given a target. For example, uh, we need to find a nonce number. Nonce means a number used once. Uh, a nonce which will get hashed with the data of the current block. So as to create a hash that has these many initial zeros. That is my problem statement. That is my puzzle. That we have to find a nonce, a number which when combined with the data of the blockchain, the block that we want to validate, should produce a string, a hash that has these many initial zeros. For example, if it has only one initial zero, it is very easy to find. But as we keep on increasing the number of zeros in the starting, it will become very difficult to find that nonce. So
So
that is the puzzle about it.
where is this written? Like I have sent a link. So where this problem is written? I have opened Puzzle 71.
I am sharing it in the tab.
One second. Now explain.
See, I will try to explain it from starting. Uh, just follow me. Don't follow this page. I'm stopping to share. Okay. Uh, See, in a blockchain, we are given uh, two portions there. One is header and the second is body in a block. In a block, there is a header, there is a body. In the body, we keep all the transactions. In the header, we keep metadata and some other things. So in the header, we also keep a target. Target means how many. For example, if my target is, let's say, 5, that means uh, uh, 5 zeros should be in the starting of the hash that I get after concatenating the data of the blockchain, the block, and a nonce. Data of the blockchain and data of the block and the nonce. I concatenate them and then hash them. Then then I should get a string that has 5 zeros in the starting. That is my problem statement. How do I get this problem statement? I just look into the target field of the header. Are you getting this?
No,
There
I
is a
didn't
block.
get it.
Yes.
No, didn't get it.
Okay. Let me try it once again. Forget about the puzzle link that you sent, Sushmit. Uh, um, I will try to explain it once more. There is a block. Okay, it has two parts. One is header. The second is body. In the body, there are contained multiple transactions that we already discussed. In the header, there is one unique field apart from some other fields that is called as target. Okay. In the target, it is written the number of zeros. For example, let's say the target is 5. Okay. So there is a block that has target equal to 5. Now, in order to validate this block as a miner, I will have to find a nonce, nonce, nonce. Nonce means number used once. That is my x. Okay, let's not say it's nonce but x. We need to find this x so that when I concatenate x with the data of the blockchain, that means I write first transaction, then second transaction, then third transaction, then fourth and so on. And after that I write plus the number. Okay, the x. Then I hash this all. Hash is a function. So if I apply hash over this, then the resulting string, that is let's say of 50 characters, should have initially in the starting 5 zeros. Is it clear now,
Okay, get it. Yes.
Sushmit?
Yes.
Are you sure?
Yes, the result
Yes.
should be a proper pattern. And this is the tough thing because we don't know the input, what input we do, we give in the hash, and it will result 5 zeros in the initials.
Yes.
That's why it is tough.
Yes. But yes, exactly. This is tough because we simply have got one option, that is brute force method. We will keep
Yes.
on trying different numbers and see if it is, see the result. And if it falls, then we are done. If it doesn't, we try with the next number. But
Yes.
one point is there that if I change the target to 6, then it becomes more difficult because my search space reduces. Right? Earlier, I had a lot of correct answers when only 5 initial zeros were there. If you apply simple PNC, like how many 50 character strings can be there with 5 initial zeros? That is a lot of strings. But if I say 6 initial zeros, that is lesser strings, right?
Mm, but yes. Okay.
So that is the way. So now it will take me more time to get the answer right, because earlier there was a greater chance to get the answer right by brute force, but now there is a lesser chance because my correct answer space is shorter now, simply by increasing the number from 5 to 6. Okay, so that is how the puzzle is made harder and harder every week. So I think the tab that the thing that Sushmit shared, that was showing me that target as I don't know how many zeros are there, but that is a lot of zeros, not 5 or 6. I think more than 30 zeros are there. Okay, so um, So that is the idea that as we increase the target, the puzzle becomes more difficult because my search space becomes shorter and shorter. Um,
But you said that if target number increases, then the search space decreases. Then it should be easy, right?
no,
Easier.
there are lesser correct answer. Earlier there were a lot of correct answers, but now there are lesser correct answers. It is not like it's just one correct answer, one correct X is there. There are multiple, not X, but the hash that will lie in writing the appending X to the data of the blockchain, the block.
Oh, okay.
Like if I keep on trying randomly with different X, then there is higher probability uh, to get if it starts with, for example, if I say it should start with only 1 0, or let's say no zero, it can be anything. Then in the first attempt only I've got the answer, right?
Okay, okay.
But now
Yes,
I've said that it should start with 1 0. Then I need to make some attempts. It will be easy, but I need
yes,
to make some attempts. Maybe 26. Some attempts I have to make. Okay.
yes, yes.
But if I keep on increasing the number of zeros, then I will have to make more and more attempts. So that is how I make this puzzle harder.
Yes, got it.
Okay, so next time we will dive more deeper. Uh, but I hope the aim was fulfilled. We have achieved the aim to understand basis of blockchain. Uh, I don't know
But
what are you.
yes, but yes, yes, but still, I cannot make to the link of the puzzle and the validating purpose. Like who, like what in the puzzle, what we are, what we want to match. Like still, it is not clear.
We want to match that initially these many zeros should be there.
So, what is the string? Like these string? What is the string? Like
What is the
where
string?
it is written,
String
who
can be
provide
anything.
that? Like who provides the puzzle?
So the target, once you are given um, the target is for example 5 or 6. So the puzzle is already made for you. You need to get um, the data of the block and append a nonce to it, then hash it. Hash function is already defined. Which hash function we have to use, that is already defined in the blockchain protocol. So that hash function gives us the result that is of about 50, not 50, but I don't remember the exact number. So just for example, 50 character string or 100 character string. So that
Oh,
function is
okay.
already
That
defined in
means
the protocol. Which
yes.
function we have to use for hashing? Hash function.
Mm. So each time I provide that same input, that will provide another output in each step.
Yes, same input. That is the data of the block plus the nonce that you are feeding it, and that will give me the output. If now once the nonce is discovered, I have found the correct answer. I will broadcast the nonce to everyone, and everyone can verify it easily. They just need to try it once. That nonce plus the data, do the hash, and you will get the number with these number of zeros. So finding the answer is tough, but verifying is like a few milliseconds.
Okay. Okay. Got many ideas with this session.
Okay. So I will try to do. Let's see how I will review this once, and then I will try to do one session on cryptography. Okay.
Okay.
What about you, Sushmit?
Yeah, it was good
Okay.
session.